and you can just talk over it. That's the part that feels different.
It's a small interaction detail that points to a much bigger architectural change, but it's just one piece of the puzzle OpenAI released.
I'm Milo.
I'm Mila.
This is AI Daily.
We're starting with OpenAI's new GPT 5.6 family of models. Later in the show, why a single number on the Nasdaq, 26.5 billion, explains the future of the hardware that runs them.
But let's stick with the software. OpenAI didn't just release one model. They released a portfolio, a flagship called Sol, an everyday model called Terra, and a cost saver called Luna.
It's a classic tiered strategy. Sol is the frontier, the one that pushes the benchmarks. Terra is the workhorse for most applications, and Luna is for scale and efficiency. They're not selling a single engine anymore. They're selling a whole fleet.
Right, and the technical specs reflect that. Sol is the heavyweight, likely a dense model with a massive parameter count, optimized for peak performance on complex reasoning. Terra and Luna are probably using different architectures, maybe a mixture of experts' approach to balance cost and speed.
And alongside the model family, they released GPT-Live. This is the voice model you were talking about, the one that allows for interruptions.
That's a non-trivial engineering problem. For a voice assistant to feel natural, it needs to handle barge-in, where the user can cut it off mid-sentence. That requires incredibly low latency, not just in response time, but in detecting the interruption itself. It has to process, comprehend, and pivot in milliseconds.
It also points to where this is all going, away from turn-based queries and toward persistent conversational interfaces. But the release wasn't entirely smooth. There was a brief moment where it looked like the flagship model Sol might be delayed.
Correct. The Trump administration made a request to OpenAI for a pause just before the launch. But after a review, the public launch was approved and it became generally available on July 9th.
That's a new dynamic. The discussion between labs and the executive branch is happening out in the open around a specific named model release. The request was made, the review happened, and the release proceeded. It's a new step in the process.
A new node in the flowchart, exactly. The end result is the models are out. Sol, Terra, and Luna are available via API, and GPT-Live is rolling out to users. The open question is how developers will use a tiered offering like this. Do they build applications that dynamically call the right model for the right task?
And what does that do to the competitive landscape when your rival isn't just one model, but a whole price and performance curve? So OpenAI has new, more powerful models. Those models require more powerful hardware. And that leads us to our second story, the money pouring into the supply chain.
A lot of money. SK Hynix, the South Korean memory chip giant, just raised $26.5 billion in its U.S. market debut.
Let's just hang on that number. It's the largest ever U.S. market debut for a company that isn't American. The demand was enormous, and regular trading began on the Nasdaq under the ticker SKHY.
And all of that capital is earmarked for one thing: building more fabrication plants, or fabs, to produce high bandwidth memory, HBM. It's the single most critical component for AI processors, and it's a huge bottleneck.
Unpack that. Why is this specific type of memory so important?
Think of a GPU as a brain. It needs to access vast amounts of information almost instantly to do its work. HBM is like the super fast short-term memory that feeds the processor. It stacks memory chips vertically, creating a much wider data pipe. Without enough HBM, the most powerful AI chips in the world would just be sitting there, starved for data.
So the release of a model like GPT 5.6 Sol directly translates into demand for a physical component made by a company like SK Hynix.
Directly. The AI supply chain is a stack. A new model at the top creates a massive pull on the layers below it: software, networking, and the silicon itself. A $26.5 billion IPO isn't just a financial event. It's a signal of a physical constraint in the system. The market is betting that the demand for HBM will continue to outstrip supply for the foreseeable future.
We have the new models, we have the capital flowing into the hardware to run them. So where does the human element fit in? That brings us to our third story.
Right. Who is going to connect the frontier models to the thousands of businesses that want to use them? Tata Consultancy Services, or TCS, just gave us their answer.
The company is assembling a team of up to 8,900 engineers, and their focus is specifically on artificial intelligence opportunities and potential AI acquisitions.
This isn't an R&D lab trying to build a foundation model. This is an integration army. TCS is one of the world's largest IT services and consulting firms. Their business is to go into large corporations and make the technology work.
And they're not just building, they're planning to buy. The strategy is to acquire smaller, specialized AI companies and use their new engineering team to scale that technology for their clients.
It's the part of the AI economy that doesn't get the same headlines as a model release, but it might be just as important. It's the last mile problem. An API for a model like Sol is powerful, but it's not a product. A team like this is designed to turn that raw capability into a specific business process for a bank or a retailer.
I checked the numbers again. The scale of this team is significant. It's a clear signal that the enterprise market is moving from experimentation to mass deployment.
Exactly. The value isn't just in having the best model, but in the expertise to integrate it. TCS is betting that the companies who win will be the ones who can manage that complexity.
And that's our show. New models, new money for the hardware, and a new army of integrators to wire it all together.
All in a week's work. This is AI Daily.